last session we have discussed about the basic functionality of data link layer. Today we are going to discuss about the functionalities of network layer. I hope the screen is visible to all. The basic functionality of network layer is routing and forwarding. This is the initial task of network layer. Routing is the process of selecting the best path among the routes through the network between multiple networks. So it is a process of selecting the optimal path in any network. So for that, we are using a special device called routers. So routers is a special device that is work in the network layer of the OSI model or TCP IP model. So that is working in the layer 3, that is network layer. So it is a device that simply forwards the packet based on the optimal path available in the route. So for that, we are using some algorithms for routing the packets. The routing algorithm is nothing but it is a software. So it is used for selecting the optimal path through which the packet can be transmitted in a network. So for that, we are using some metric to determine the best path to deliver the packets. So the metric is standard measurement. It can be a hop count or bandwidth or delay or load that can be used as a metrics. So most probably we are using the cost or hop count. That means the number of passes to the next node. That is used as a parameter for selecting the best path. So each router maintains a table. So initially it stores some information and periodically it obtains the information from the adjacent nodes and updates that table. So every router has a table. So it consists of the routing information of adjacent nodes as well as all the nodes. So this is an example of routing. So the source node can select any path to reach the destination, but we have to consider which path is optimal in case of any parameter, cost wise or bandwidth wise or hop count wise. We have to select the best path to reach the destination. We know that the devices are identified using IP address. So the routers identifies the IP address for destination and selecting the best path for reaching the destination. So the routing can be classified into two categories, static routing and dynamic routing. In static routing, the routing paths are not decided by the router. Here, the network admin has to manually update the table. So he has to select the best path based on the traffic. In dynamic routing, the devices are automatically update their table based on the information available between the neighbors. So periodically it gets the information from the neighbors and it updates the table. So the most prominent protocol used in routing is distance vector routing. So next we will discuss about distance vector routing. So this is a dynamic based algorithm. That means in a distributed environment, all the nodes are connected in a distributed manner. So any device can communicate with any other nodes. For that, we have to maintain a table in every router. So the distance vector algorithm is mainly used in RIP protocol and ARPA networks. RIP means routing information protocol. So in this, every table maintains some vectors and metrics. Here, the metrics is the parameter used for performing the routing cost is called as hop count. For delivery of one node to another node, that is called as a hop count 1. So here we are maintaining the knowledge about the whole network by sharing the routing information from the neighbors to the adjacent nodes. So information is sharing at the regular intervals. That means every 30 seconds, the neighbor share its information to the adjacent nodes. So from that information, that nodes updates its table periodically. So distance vector routing is purely based on Bellman-Ford equation. That means here we are calculating the minimum cost. For that, we are selecting the node from source to destination. If the node is directly connected means there is no need of adding the values. If you are having the adjacent nodes, that is directly connected nodes, that the value is directly taken. If suppose we are having the intermediate nodes, then we have to calculate the cost of that particular node. That means x to that adjacent node v. Then we have to calculate the distance of that destination. Here x is the source, y is the destination, v is the adjacent node. So first we have to reach the source node x to adjacent node v. Then we have to take the cost value, that is path count. Then you have to add the cost value from that node to destination. So here we are taking the source node x to destination y through some adjacent nodes. So based on the adjacent node values, we are calculating the route. So consider this example graph. So here the network is given as a graph. So each node is represented in the form of circle. So here the node may be a router or any devices. That connecting path, this is called as number of passes. That is edges in a graph. The connecting path. For example, if A is directly connected to B, A is directly connected to E, A is directly connected with F. So the adjacent nodes of A are B, E and F. So likewise for C, the directly connected nodes are A, then B and D. So likewise for G, F and D. So for reaching from A to B, the hop count will be 1 because this is directly connected. For A to C, this is directly connected. So by looking the diagram, we can easily calculate the hop count. But in detail, every router has an initial table. So we will discuss that. So this is the initial table of all the nodes, that is routers to all other nodes. So here information available in all the nodes, here distance for reaching other nodes. For example, these are the A, B, C, D, E, F, G. These are all routers. These are all the destinations. For A to A, that is A to A, that is self path is 0. So this is for table of router A. This is the table of router B, likewise all other nodes. So this is the initial table. So the known information, that is directly connected information only available in the initial stage. Look at this. For A to A 0, A to B is 1 because directly connected. A to E is directly connected, here 1. A to C is directly connected, so this is 1. Here we have mentioned infinity for D because D is not directly connected. So through some point only we can reach the D. So that the distance is mentioned as infinity. So that we have to find the value for that one. For G also, this is not directly connected. A is here, G is here. So we have to pass through some nodes. You have to choose the best path. So likewise for B, most of columns are infinity because B is directly connected with A as well as C. All other nodes are far away. So all remaining values are infinity. Likewise for C, C to A is 1, C to B is 1, C to C, self path. C to C means C to travel to C. So that is 0. C to D, that is directly connected 1. All other values are infinitive. So likewise, you have to fill the initial table. By looking the values, you have to fill the values. If it is self path means you have to mention as 0. If it is directly connected means the number of passes. That means A can pass the data to the B with one hop count. That is the number of link is 1. That is hop count. If A is delivered to C means it has to pass through B, or it can be directly given to C. If it is directly given to C means hop count 1. If it is through B means here one hop count and here one hop count. So two value will be given. So likewise, you have to fill the values. This is initial table. So you have to consider the initial table based on the information available. You have to update the table for each router. So I have considered the initial table of node A. So from the previous table, I have taken only the initial table of router A. So for A to A 0, that is not given. A to B is 1. The next hop, that is the next node is B only. For A to C, the next node is C only. For A to D, there is no direct path, only infinitive. So there is no next hop. We have to find this value. For E is 1, F is also 1. So there is no connection between D and G from A. We have to choose the path. You can choose any path, but it should be minimal. So I will explain with the calculation. So for router A, so for A to B is 1. So because direct path, A to C is also 1. Then A to E is also 1. So these are all directly connected. So you can directly write the values A to F equal to 1. These are all directly connected. So what about A to D? A to D. You have to find the value of A to D. So A to D, we can pass through C. So the number of hop count will be 2. Right? A to C, you can reach to A to C because C is directly connected with A. So you can get the information available in the adjacent node C. So by reaching the C, you can go to the D node. So by reaching the B also, you can go to the D node, but the cost will be 2. Sorry, 3. A to B is 1, B to C is 1, C to D is 1. So 1 plus 1 plus 1, 3. So we cannot choose that part. So A to C, C to D. This is the best part for D. Then A to G. A to G. What is the value? Can you guess that? So we can reach to the G through F because F is adjacent node of A. You can get the information from F. So you can reach by 2. Right? Understand? We are getting the information from the neighbors. That is B or C or E or F. So by reaching the neighbors, we can go for the next nodes that are not directly connected. So here the table for A is updated. So look at the table of A, updated table. So this is updated table. So B to A to B is 1, A to C is 1, A to D is 2. Note down here 2. We have already solved that. So for A to G also 2. So the next node is we are reaching the D through C. We are reaching the G through F. This is given. So likewise, you have to update for all routers. So I will go with the another router. Router B. Consider router B. Okay. For B, so B to A, that is directly connected 1. B to C, that is also directly connected 1. So what about F? B to F, we cannot directly go to F. So the adjacent node is A and C. So you can select any path. So B to F through A is shortest. So B to A through B to F through A. So the cost will be 2. Okay, right? B to F through A is 2. Likewise, B to D. B to D. So you can choose B to C path. So you can get another 2 values. So you can reach the D from B through C. Okay. Then E. So B to A, then E. So you will get 2. Half count will be 2. For G, B to A, then F, then G. The half count will be here 3. So you can choose any path. B to C to D and G. This is also same. So you can choose any path. But the next node information will be used by that node. So here C is adjacent node, you can use the value. Then A is also the adjacent node, you can choose the value. But half count will be same. So you can take any value from these two. So we have almost reached all the nodes from B. Right? B to A is over, B to C is over, B to E, B to F. Right? Everything is over. So consider the final table. So note down the final table. Final table of B. For A, B to A is 1, B to B is 0, B to C is 1, B to D is 2, B to E is 2, then F is 2, G is 3. So likewise, you have to calculate the value for router C. Router C. Router C. So you can easily calculate C to A equal to 1, right? C to B equal to 1, directly connected. C to D equal to also 1, directly connected. C to E. What about C to E? C to E through A. I think this is the best part. C to A, then A to E. So output will be 2. Then C to G. So you can go C to D, then G. So here also output will be 2. Right? Then A to F. So this is also done by A. C to A and F. So half count will be 2. So now we get the table of C with the adjacent nodes. Note down the final table. So almost we got the same value. So likewise, you can calculate for D. So by looking the diagram, we can easily calculate. D to C. D to C is 1. D to G is also 1. D to A. So almost 2, right? Because D to C, C to A. then D to E. So D to C, C to A, then E. So for E, 3. So almost we got the right answer for D. So likewise, you have to perform the operations for all the routers. You have to calculate the table, updated table values for all the routers. Like this, you have to write the operations for all the routers and you have to write the commands for all the values. So no need to update the adjacent node values in final table. So from node to other nodes cost value, that is hop count value, is enough, because here the hop count value is the metric. So update the hop count value in the final table. So this is the traditional and most promising algorithm used by the most of protocols. So in most of distributed environment, we are using distance vector routing algorithm. So here we are sharing the adjacent nodes whole information to the nodes. By sharing the adjacent nodes information, we get the knowledge of the entire topology. So here sharing of entire table is somewhat risky process. So because the adjacent nodes only have the known values, but we are sharing the unknown values also. This is the main drawback in distance vector algorithm. So it can be solved by another routing algorithm called link state routing algorithm, that is used in OSPF protocols, open shortest path routing algorithm. So that is also another version of routing algorithms. So these are all comes under unicast routing. So I hope you have understand the basics of routing and how the distance vector routing algorithms works. I hope you have understand the basics of distance vector algorithm. Next, we move on to the next algorithm, link state routing algorithm. Is it visible? Yeah, thank you. So in the previous class, we have discussed routing information protocol based on distance vector algorithm. So with the continuation, we move on to the next topic, link state routing algorithm. So the main drawback of distance vector routing algorithm is we are sharing the complete information about the neighbors to the adjacent nodes. So it creates traffic in a network. So the adjacent nodes are talking with each other at regular intervals. That is, every 30 seconds, each node is talking with its adjacent nodes. So every 30 seconds, the table in the routers are updated. This is the good idea. But even though we are sharing the information, the whole table is shared with the nodes. So it creates burden in a network. So the best idea to reduce this problem is to share the known information to the adjacent nodes. That's why we are moving to the routing algorithms called link state routing algorithm. So in this, we are sharing only the known information of the adjacent to the nearby nodes. So every node knows how to reach its directly connected neighbors information. So that knowledge only stored in each node, that is shared with the adjacent nodes. That is the main advantage of this link state routing algorithm. So this is reliable transmission. That means it creates reliable transmission in a network without flooding. So if we are sharing the entire information of the router, it will create a traffic in a network. So here we are calling the packet called link state packet, that is LSP. That is the known information only given to the adjacent nodes. That link state packet consists of the following information. So every LSB has an ID, then directly connected neighbors information, then it has a sequence number, and a time period of life of that particular packet. Then that is used for the calculation purpose. So here the entire topology information is shared with all other nodes in a network, but only the known information is shared. So it will not create a traffic in the network. For example, X share its information to the A, then and adjacent node C. So these two are adjacents for X. So then these informations are passed to the B, then D. So the entire information is known to all the nodes in a network, then only the known information is shared with the adjacent. This is the main advantages of link state routing algorithm. So consider this graph, simple graph for link state routing. So here we are going to calculate the cost, minimum cost from one source to other nodes. So you can choose any path from source to destination, but it should be minimal cost. So here we are not considering the hop count. Here the cost as a metric. Here we have to consider the cost value as the parameter for calculating the distance from one node to other nodes through adjacent nodes. So in this format, we are following different procedure. So this is somewhat complex when compared to distance vector routing algorithm. Here we are maintain two list of parameters, conform list and tentative list. Then you have to write the comments. So this is used for our understanding. So you can choose any node from the diagram as a source node. So in this example, I have choose a D as a source node. So you have to reach through from D to all other nodes. Then you have to calculate the best part. So for example, you have to reach from D to C, then D to B, and D to A. So here D to C and D to B are directly connected. So you can easily calculate the values from D to B and D to C. But you have to calculate the step-by-step values. So move on to the procedure. Then I have taken the D as a source node. So here we have three split ups. The first one is the destination node, then the cost, then next hop. So initially D is the source, D is the destination. So D is the destination, D is the source. The cost to reach the D is 0, then there is no next hop. So this is the tentative as well as confirmed list because I am taking D as a source node. Next, find out the value available in the D node. That is, D knows about B and C. That means you can reach to C and B because these two are directly connected. That values are mentioned here. So you can go to the B with the cost of 11 and next node will be B. And you can go to the C, the cost of 2 and C. So this is taken from the diagram. So D to C, D to B. So this is given. So from D, you can go to the B and C. So you can choose any part, but we have to choose the minimal value. So here D to B is not good because the value is 11. So D to C you can travel because it has a minimum value. So the minimum value is moved to the confirmed list. So we are taking the option in the tentative list and we are moving the minimal value to the confirmed list. That means now you are moved to the D to C. So for this diagram, now you are in D to C. So using 3, you can go for A as well as B. So you have to calculate that values. So now the B value is still here. Okay. So now we have to check the LSB of C. So from D to C, where you can go. So you can go to the B with the value of 5 through C. So refer this one. So if you are directly going to B means 11. If you are taking this part through C means 3 plus 2, 5. So you can take this value. So here, this whole value is replaced because cost to reach the B through C is 5. So we can replace the highest value. So even though we are having the direct connection, but through C is minimal. So put that value. So this old value is replaced. So consider the commands. So here we are clearly mentioned the commands. Okay. Then you can go to the A. From D to A through C. That is 10 plus 2. Okay. So here 12. So that is given. Okay. Next we move on to the confirm list. We have to move some value to the confirm list. So in these two, B is the minimal value. So move that B to the confirm list. So now we move to A to C. Now we are in B. So in this position, you have to check the values. So from B, you can reach the A. Then C. We have already minimal value for D to C. So we have to check the value for A through B. So D to C, then B, then A. So 5 plus 3 plus 2. So we get A with the minimal value 10. Yeah, right. Already we have 12. But through B, comma C, we get A with the minimal value, that is 10. So that is given in the updated list. So even though you are having direct value, you are updating, and the remaining values are also updating based on the movement. From D to C, we are moving. From C, we are taking the shortest path B. So by using the value of B, we can reach to the A with the minimal cost. So previously we have A with 12 value through C. Say here A comma 10 comma B comma C, that is hidden. B is hidden because D to C comma B comma A up. That is actual value. So that is hidden. So we are taking minimal value A of 10 to C through C. That is given in the confirm list. So now the confirm list is over because we have reached all the nodes. D to C is over, D to B is over, D to A is also over. So directly connected value is also useful. Then the known information from the neighbors also useful. So these two are updated. So keep on updating the table based on the information available in the neighbors in a periodic interval. So the final values D you can reach with 0, you can reach the C through T 2 value, P through 5 and A through 10. This is the use of link state algorithm. So this is the protocol based on link state algorithm, that is open shortest path algorithm. Actually the algorithms are information based. So actually it is used in some software. So this is a software, that is a protocol based on the link state algorithm. So finally you have to draw the subtree based on the given table. So that is the assignment for today's class. Complete the assignment. If you have any doubts, we will discuss in the next session. Thank you.